All right, so welcome everybody to another Cast to Condensing webinar, a webinar series where we are talking about all the things that you need to know as you go and convert a building from an atmospheric cast iron boiler to a high efficiency condensing boiler. And there's a lot to know. This is part three of this series of webinars, right? If you've missed the first two, encourage you to go back and look at those two. They were recorded. Just like this one's being recorded, just so you know, and so yourselves and others like you can go back and look at this content at a later time. And if you've got any questions as we go through this presentation, feel free to enter those into the Q&A section here of the Teams meeting, and we'll get to as many of them as we possibly can here at the very end of our time here today. So we love questions, so make sure you put those in. And another guy who likes questions is Dan. Dan Reddig is our product manager for HSSC. He covers all the boilers within three brands of different boilers: Thermal Solutions, Bryan Boilers, and Burnham Commercial. So quite a bit to know there, and certainly very relevant content and information and experience as it comes to this conversation here today. So without further ado, Dan, part three of the series. We haven't covered it all yet. What are we talking about here today?
Yeah, thank you, Charlie. So I'd like to apologize to everybody before we get started. Traveled last week and I brought a cold or a virus home with me. So, was out getting voice of customer and brought more home than I wanted to. So working to get over that, but I think we can get through the next hour together. So as Charlie said, this is the third webinar we've done in the series. So this webinar will be a little bit shorter than the previous. We were right up to the hour on the previous two, but today we'll be talking about hydronic piping, some questions that come around like common manifold sizing, why do manufacturers, have the recommended sizes they do, some common problems with variable speed pumps, with the flow rates. We'll talk about that and just different piping configurations. And then we'll get into kind of been a pretty hot topic in the industry for the last several years, water quality. As more and more high efficiency boilers have got accepted into the market, installed, what's kind of popped its head out, is that these units have small passageways and are more sensitive to poor water quality. So we need to make sure we're aware of what that water quality is in the systems we're putting it in. So we'll talk about that. And I kind of got reference manual on the screen. I think this is a big takeaway. If you go back 10 years ago, if you looked into any boiler manufacturer's manual, there'd be minimal reference to water quality. Now you can pick up 10 manuals and you're going to see some kind of reference to water quality, different types of filtration, air separation. So the industry is going in the correct direction to provide good guidance for specifying engineers and installers. And then we'll talk about indirect water heating. That is an option, that we have with our hydronic systems, that we can also provide domestic hot water. And to do that, we need to go through means of indirect water heating. We'll talk about those different configurations: tanks, brazed plates, plate and frames. And then we'll talk about some of the sizing characteristics you need to look at and some of the pump sizing with that. So with that, we'll go ahead and get started with the common manifold piping that we talked about. So this is from one of our manuals, but you're going to see similar common manifold piping, in all manufacturers. So what you'll see if you look at that 800 model, the fourth one down, and if you go over to, number of appliances 6, we want that to be 8-inch, right? And so the first thing somebody's going to say is, well, Dan, that is super expensive to run 8-inch pipe. Can't argue with that. So what they'll say is, can I go smaller? Yes, you possibly can go smaller, but you have to remember, as a manufacturer, we have to reference worst case scenario. So worst case scenario is what? Maximum flow rate. So we need to make sure that we're not pushing too much velocity through that pipe. Velocity can create a lot of issues, noise being one. And then if you're not monitoring your total dissolved solids, right? If you start to flow too hard, through a pipe, right, you can start to get pitting in your elbows. So there's a lot of reasons why we want to make sure that pipe is sized correctly. But again, you're going to see worst case scenario in all the manufacturers' manuals. So when you look at that, we referenced, maximum flow. So if you look at that same 800 down there, and if you go off to the far right, second column from the far right, you'll see the maximum flow. So we're saying 103 GPM. So again, that's going to be okay. If you're flowing 6 units at 103 GPM, we're going to recommend you have 8-inch pipe for your common manifold. But if you could decide to go over and go with the minimum flow, which is going to give you a higher delta T, you'll see it a 50-degree delta T, right? That 8-inch common manifold is not really going to be necessary. You can probably downsize that. You would have to do those calculations to see what that size is. But again, we can't put everything in the manual. We'd like to, but instead of a 80-page manual, it becomes a 400-page book if we put everything in the manual. So, but you'll just kind of want to look at that and use your judgment and calculations for your system. But that is a pretty common conversations that'll be had on this common manifold piping. Why is it so large at times? And that is always going to be towards the maximum flow. And then also in this chart, you're going to see, just your basic, the one at the bottom right is going to be your recommended range for delta T's. You're going to have this provided by every boiler manufacturer, and that's going to allow you to properly size a pump. A lot of manufacturers for boilers will offer some kind of pump. If you have a specific brand you want to use, you may not be able to source that brand from that manufacturer. You can always go through your local pump rep to get that specific brand, but most manufacturers will provide some kind of pump in their catalog. And they'll usually have a recommendation on what pump to use with what model. So let's get into a little bit of the piping. So this is going to be just a basic primary, secondary piping configuration. You're going to see here is the closely spaced T's. This is pretty common setup here, for years. Now, what a lot of people will say, okay, well, if I get these T's spaced correctly, that's it, right? I've done all I've got to do. I don't have to worry about anything else. That is not necessarily true. And what I mean by that is you still got to take into consideration flow. So let's say out in the system here, we have this variable speed pump, the system circulator. It's variable speed, so that speed is ramping up and down. Could be anywhere from 500 all the way down to 50 GPM, depending on what's going on out the system. So if that pump is running at, say, 50 GPM, because that's what the system's requiring, and you've got your boiler circulator here, which is actually operating at 100 GPM, this is a pretty common thing here we're talking about that happens with the introduction of variable speed pump. What happens is this boiler circulator will start to pull water back through the inlet. So what it's going to do, it's going to recirculate that. And what happens here, a couple things, right, is you start to pull back warmer inlet water temperature. So you're no longer pulling from the system, you're pulling from the discharge of the boiler. So now if your boiler's discharging 180, you start to suck that 180 back. You are mixing a little bit of that in from the system return. So it's not going to be exactly 180, but you will have higher than desired return temperatures, which is then going to make the unit have to modulate to correct itself. Depending on the logic in the unit, it may be able to catch itself a little bit, but eventually all that's going to happen is this unit's going to go off on limit. So you're going to see this with any boiler. It's just a dynamic of delta T and pump operation. So this is something to be aware of. And one way you can resolve this is you can put a buffer tank in place of the closely spaced T's there, or you can do a hydraulic separator. What that will do is give you volume, and it'll allow you to separate those flows. So you'll want to size both of those devices accordingly. what you'll do is you'll have to know the GPM range out in the system and the GPM of the boiler. But that is, if you're not willing to adjust the system circulator speed and you have this issue going on, you're going to have to put some kind of buffer of volume in between those. Or, you just turn down the system pump, or turn up the system pump so it's always flowing more than the boiler loop, pulling those BTUs away. This is what is often called a full flow system, or a primary variable system. So this is where there is no closely spaced T's and we are flowing through each boiler. In this diagram, you're going to notice here is an isolation valve on each boiler. So in this scenario, these isolation valves could be controlled by the system BMS, by the boiler manufacturer, or a third-party device. What you want to be careful of is if all three of these valves close and the pump is still running, you start the pump will deadhead, and then what happens is you end up blowing the relief, and then once that happens, you're dumping water and glycol out of the system. So as you guys know, that glycol is very expensive, and then it becomes, well, who's responsible for that? Is that the person controlling the valve? Is that the boiler manufacturer? So it's just an issue that none of us want to deal with in the field, but that is something that can happen and does happen a lot in this scenario. Even if somebody's controlling the logic on a regular basis and doesn't have any issues, that doesn't mean that some kind of bug can pop up and one of these isolation valves may close on accident. So it's really just a dynamic of what happens in this situation in this piping arrangement. But this is something that I've seen over the years happen quite a bit. So one way to avoid this is if you're doing a system like this, and so in this scenario, there's only going to be one boiler, but it's this kind of still the same full flow variable primary system. You put in a differential pressure bypass. So what that can do is you set a minimum flow rate required for the system. So no matter if the valve shuts at the boiler, you're still going to have some flow going through the system. So now that you don't deadhead the pump and you don't build up pressure. So most systems, as you know, are going to have a minimum flow rate. So this can be just set at that minimum flow rate, and you can maintain that system flow if you want to isolate the boilers when they're not operating. In that previous scenario, a lot of people like to isolate the boiler because they don't want flow going through a non-firing boiler. But again, we just need to be aware if there's nowhere for the water to go, it's going to find somewhere to go, right? It's going to exit the system. So now we'll get into water quality. So as I said at the beginning of the presentation, we have took major steps in the industry towards water quality. I remember the conversations 10 years ago. It was like, well, what is the recommendations of the manufacturers? A lot of us were just kind of standoffish. We'd say, go talk to, the water quality experts. But we all realized that was not, that we can no longer kind of hold that line. So what you started to see is everybody was getting parameters put in their manuals, giving different recommendations. I would say we're still not all giving the same recommendations, but we do have recommendations. So again, like I said, we're in a lot better place than we were 10 years ago as the industry. So right here, you'll see our water quality requirements as far as water hardness, the total dissolved solids, the chlorine and the pH. So kind of referenced the total dissolved solids earlier, right? So that's just all the nasty stuff that's in the water. And you can see our maximum is 450 ppm. So what I was talking about earlier with excessive flow, velocity and piping, and if you aren't monitoring your TDS, that's what you can start to see is pitting in the 90s or anywhere where that water kind of hits the pipe and has to move. So even possibly in a T, you may see some pitting. But again, that's not unusual. But now with these guidelines, I think a lot more people are paying attention to their water quality. So we do give good recommendations. And now this is also something that I think is interesting. You're going to start to see is the reference to water meters. So there's going to be recommendations that says, hey, put a water meter in your system. That way, if it's leaking, you can actually verify. Through the years, I've been on many job sites. You go there and they're like, oh, my system's not leaking, right? Or it's a small leak. So if the system is leaking, what happens is you're introducing fresh water into it. So that fresh water, if it's not being treated, right, that system becomes more like a open loop water heater, domestic water heating system than it does a closed loop hydronic system. So kind of give an example here, one job site, they didn't have a water meter. We was pretty sure the system was leaking. So we actually turned the incoming water off, came back the next day, and that system had been operating at 20 PSI. Sorry. And when we came back, the system was like at 8. So it had lost a significant amount of water. So then what we did is, we got there to get it running. We opened it back up, system filled itself back up. So after that, they installed a water meter and did find out that they had a pretty significant leak, and then they had to go locate the leaks. And this was a system that had a lot of buried pipe under the ground, so it did take them some time to resolve those leaks. And miraculously, right, they were having failed units about every 6 to 8 months, and then once they fixed their leaks, never heard back from them, at least for a couple of years. At that time, didn't completely keep track of that job, but that was a job that we were having a lot of contact with. And then once we found out there was a leak, they got it resolved. That how frequently we were making contact with that customer went away. So here is a reference to different inhibitors in scale, corrosion scale inhibitors. There's many manufacturers out there. You'll see there's Fernox here on the screen, Sentinel, Addy. Sorry. What I would recommend is that you reach out to the local representatives of some of these inhibitors, and have conversations with them when you design your system or you go to fill your system, and find out what's going to be best for you. And then also there are local chemical manufacturers, and representatives that will help. They have different solutions. These are just sorry. These are just the top 4 that are really focused on the boiler industry, and so most of the boiler manufacturers have good relationships with them. So you'll see them referenced throughout their manuals. And then also just off to the right is just the glycol solution. And I believe everybody knows this, but just in case if not, right, the more glycol solution you have, that adds extra pressure drop in the system. So you got to size your pumps accordingly. So you'll see at a 50% glycol, you're going to need to increase your flow by 24% to get the same heat transfer. If not, the system won't perform as you thought it would. So just something to be aware of. And that's a general rule of thumb. Each glycol will have a different D rate associated with it, but that is a good rule of thumb there. Let's get into kind of some other accessories. Obviously, we don't manufacture these accessories, but I think it's good to have conversations about. So if you look at some other things we can do for water quality, you look at magnetic filters. If anybody has not went to YouTube or Googled, magnetic filters, I would recommend doing that after this webinar and just see some of the junk that's in these systems, right? You've got people online that'll put these magnetic filters in, and they won't even run the system for a day. They'll go to lunch, they'll put it in, they'll go to lunch, they come back and they pull out these magnetic rods, and they are just covered in junk. So where does that junk end up, especially if it's magnetite or something? It's going to end up on your variable speed ECM pumps. It's going to end up on in your boiler. It's going to find somewhere to live. It's just not going to float around the system. So we want to get rid of that. But again, I would highly recommend somebody, if you aren't familiar with magnetic filters, to get online, kind of look at them, especially in any kind of retrofit system. I highly recommend some kind of magnetic filter. And then air eliminators, right? I think one of the major issues with hydronic systems is air elimination. Probably don't talk enough about it, but we want to make sure we're getting rid of all the air in the system. And to do that, there's different manufacturers out there that have different devices, but we want to make sure that we get rid of that air, because that air will actually kind of degrade the glycol. So if we went ahead and spent a bunch of money, put money into the system, putting glycol in there for protection, if we don't get rid of the air, that air is going to actually eat away at the glycol, and then your investment in the glycol is useless, because you're going to have to, replace that glycol. Also, the air in the system will start to eat away at and cause corrosion of any kind of metallic pipe over time. So again, we want to remove as much air and continue to remove air. That's another thing. If you have a system with a leak and you're introducing fresh water, what are you also doing? Introducing air with that every time you introduce fresh water into that system. And then this is something that I was unaware of until about 5 years ago. So I think we all learn every day in this industry. But recommend that you fill the system with demineralized water, right? No clue. I remember we started off doing this 25 years ago. We would install a boiler, just crank the water up from the system and let it go. Worst thing we could have been doing for the boiler system, right? So now a lot of manufacturers have these demineralizers where you hook up the fresh water. It'll filter that water and then introduce it into the system. So now you're putting clean water, giving yourself the best chance for success, at the beginning. We've treated the water, we've done all we could, so we demineralize it. We'll put glycol, some other inhibitors in there, and then we'll also look at these magnetic filters and air eliminators. That's going to give us the best possibility for longevity and high efficiency system. So what happens if we don't look at water quality? Right, you're going to end up having failure. So this is a top tube sheet of a boiler, and you can start to see this is a buildup of scale and magnetite on that tube sheet. So that tube sheet, gets coated with that magnetite. It kills the heat transfer, and then the next thing the boiler gets a leak because it overheats. So manufacturers are not shipping boilers with magnetite and scale in them. It happens because of the system dynamics and either leaks in the system or lack of poor water quality. So this will happen to anybody's product. It's just going to be a matter of time if you have bad water quality. But it is more common. You're going to see these with high efficiency boilers because of the passageways. They're smaller, so that the potential for them to get backed up with all this scale and magnetite increases dramatically. So that's why, the system ran previously for 30 years with a cast iron unit. Well, those passageways are bigger. You didn't see these kind of issues, but now this is a common issue with high efficiency boilers if we ignore the water quality. So I want to kind of finish here with the last section of the indirect water heating. Stole these from our residential side of our business. Just have a clear, precise image. You'll see here is a boiler in the middle, and off to the right is a indirect tank. This is what I would refer to as you're going to pipe right off the boiler loop with your indirect tank, and you've got this pump. So now when you do this, that pump has to be sized to overcome the coil in the indirect tank there to the right and the heat exchanger in the boiler. If you don't take into consideration both of those in the sizing of that pump, you're not going to get the performance of the indirect tank, because you will not be getting the temperatures and flow you need through that through that tank to get the heat transfer. So this a lot of people like this piping arrangement here because they don't have to heat up the system. So if I'm doing this, I heat that boiler up, I heat it up to 180, and then I pull that 180 directly into the indirect tank. I transfer those BTUs into the tank. It goes right back to the boiler inlet, and all that heat kind of stays right there, right? So the bad thing with this is there's really no redundancy, because if I had two boilers in this scenario, right, how do I connect the two? To do that, now you've got to go connect out into this system. So in this scenario, you can see that the indirect tank off to the left is hooked to the system piping. So this scenario on this drawing, I only have one boiler to the right, but if I had two, now in this scenario, right, I can get BTUs from both boilers. Now, one advantage to this, right, is this pump here only has to be sized to overcome the pressure drop inside the indirect tank. We no longer have to worry about the pressure drop in the boiler also. Now, one thing that can be a downside to this configuration is now I've got to heat this loop up to 180, right? So if the boiler's firing 180, it's going to get up here. If sized correctly, you know, I'm going to pull all those BTUs into this indirect tank. But for some reason, if it's not sized correctly, you know, I could have some heat migrate out into the system. You may not want that heat out there. It just really depends on the system design and how everything's sized. So, you know, there are advantages and disadvantages to each system. But either way you go, what you want to make sure is that the indirect tank is sized to pull away the BTUs. So if you have too much boiler horsepower, so if you have, let's just say, a 300,000 BTU boiler and the indirect tank can only hold 150,000 BTUs of energy, right? So what's going to happen is a couple things, right? That tank, right? You continue to run. You're going to have possible issues with the boiler if the boiler is not able to reduce its capacity. So some manufacturers will have the capability to go in there and say, okay, we'll only fire the boiler for domestic hot water at 150,000 BTUs to exactly match what the indirect tank needs. So that'll help with some of the short cycling of the boiler. But if not, that's what you're going to see is the boiler will short cycle if you're putting too many BTUs in the indirect tank, because what happens is, you know, one, you could overheat the indirect tank, but then two, also, right, your return water temperature is going to get too high to the boiler. So we talked about your standard indirect tank right there in both of, you know, those drawings. So that's over to the right was what that tank would look like. You would have a pre-assembled from the factory tank with a coil inside, completely welded together to the tank. And that's going to be pretty easy on your sizing. The manufacturers are going to say, you supply this tank 180 degrees at 15 GPM. You know, that'll give you a recovery rate of X in this 119 gallon tank. So that's typically going to be the largest you're going to see in an indirect tank is 119 gallons. And then it'll go down to probably 80, you know, that 50 range, maybe down to 30 or 20 gallons on an indirect tank. The hot water generator is going to be a very similar setup, but it does leave you to some customization. So now you can customize the size of your tank depending on your load and your recovery rate. And also you can change that tube bundle. So in the indirect tank we have on the screen here, I was talking about that tube bundle's fixed, or sorry, the tube there is fixed. With the tube bundle, the manufacturer can just replace that, and that can have actually different performance. So you can work with the manufacturers of these hot water generators and actually size one to your system. So that's what's nice about a hot water generator is you're going to be able to get larger volume and get some customization. And then we have this in the industry, a reverse indirect. And what that does is it actually previously we were providing the boiler water through the coil. Here the boiler water goes into the pressure vessel. So now that pressure vessel kind of becomes a buffer tank and your heat source for the domestic hot water. So you'll see on the screen to the bottom right, the domestic cold water comes in and it goes through these tubes and then out. So this is what the industry refers to as a reverse indirect, more of an instantaneous type style where you're not really storing the domestic hot water, you're storing the boiler water here. And this is going to have similar sizing recommendations. You provide the pressure vessel with 180 degrees, stored water, and you'll get X performance out of the coils. And then what's kind of became, I guess, a little more common, a little more desired the last 5-6 years is using a braze plate or a plate and frame. You'll see these just a basic plate and frame, a braze plate, and then you'll also see them with a digital control. So the digital control will obviously add cost to that platform. But the biggest downside to these is, right, these are instantaneous, but this is the boiler side of the system. So if you don't have at all times 180 or 160 degrees here, once you get that domestic flow, what are you going to be doing? You're going to be delivering cold water to the occupants or whatever your application is. You need that domestic hot water. So these work fine long as you design into your system that you have a constant flow of 160, 180, whatever you need to transfer to that domestic hot water. So that's been the biggest downside to these is people are like, oh, well, they're instantaneous. They are, but if you're not prepared to have the BTUs on the boiler side ready to deliver those BTUs, it's not instantaneous because once the domestic flow starts, if you're waiting for that boiler to go through pre-purge, you're probably 45 seconds to a minute. Then the boiler's got to fire. Then it's got to ramp up temperature. So you could be 2 to 2.5 minutes until 180 degrees gets to that braze plate or plate and frame to start transferring the energy. So that is, like I said, these systems work well, but you just got to make sure that you take into consideration you have the BTUs there to transfer. And then I've showed this the previous 2 webinars. Again, we've been talking about cast to condensing, and that's great. But every job may not lend itself to going that way. So again, there's nothing wrong with just going straight back with what your system currently has. If it's a cast system and you want to go back with cast boilers, that's completely all right. All right. So kind of close up here with what condensing products do we provide? So, Charlie kind of talked about the 3 brands. So I'll talk about what we have underneath the thermal solutions line. We have the Apex boiler. So that's going to give you 5 models from an input of 399 to 800. We've got the amp. So that's going to be a total of 13 models, the 399 on the input up to 4 million. And then we have our Arctic, which is a total of 11 models, the 999, the million BTU, all the way up to 6 million. So if you're looking for a condensing product and you want to investigate our thermal solutions line, I just ask that you reach out to your local manufacturer's representatives and they can get you the information you need. But we'd like to be of assistance to you in any way we can. So kind of in summary here, I'm about to lose my voice. We're probably all glad here this is about to get over with. We talked about the hydronic piping, just again, the common manifold sizing, just need to make sure to check your flow rates. What is it going to be your flow rates? If you're going to go maximum flow, make sure you're going to size it accordingly. Do not try to get, price sensitive and go with the small size pipe and then, have too much velocity going through that pipe. Right? Variable speed pumps are great, energy efficient, and they can really maximize the system. But we do need to be aware of how that system and the boiler circulators perform together, because they can create issues if we're not aware of how they work together. There's different ways to pipe these boiler systems. Any way works good, but they can all have issues if we aren't aware of what issues to look for. Water quality, I can't state enough that I believe we're going in a good direction as an industry, trying to give better guidance to water quality. I'm sure we can do better, but again, we're in a lot better place now than we were 10 years ago. And then indirect water heating, right? I think that's overlooked a lot in the industry. People want to do, a separate domestic hot water system. Most of our boiler systems do have a little bit extra capacity. There's a little bit redundancy. So it's probably not going to hurt from the heating capacity if we use a little bit of those BTUs to heat the domestic hot water indirectly. We just want to make sure that we size those correctly and we're using the right configuration for our demand. So with that, I think, Charlie, I'm going to turn it over to you for any questions.
Sounds good. Well, yeah, thank you, Dan. Yeah, that was definitely some really good information. And I have to say, yeah, people weren't really interested in the content. I'm sure they were super interested to see if you're actually going to make it through this presentation there. So congrats on that. But you're not done yet. We've got a couple questions for you. So not off the hook yet. Yeah, just a couple questions here. So I guess when you finished with the water quality side of things, when it comes to water quality, you mentioned the manufacturers putting out some of those specifications, those standards. I mean, is there any kind of overall overarching standard for water quality in these systems that you're aware of, or anybody working on that?
So that's actually a really good question, Charlie. So, there's been some work going on for years. I believe IATMO just kind of finalized something a couple of years ago and got that released. I'm not sure how that's being implemented, to be honest with you, or ever what is in those standards, but I do believe there was some work recently done. But Europe has had a standard for years. It's pretty intense when you look at their standards. So it's like based off the water volume of the system, and then that kind of gives you a range you need to be at for your certain parameters. I know that was getting looked at years ago by some different associations in the U.S., and they just said, man, there's no way we're going to be disciplined enough in the U.S. market to do that. So, I probably need to investigate a little bit more on this IATMO standard just to get familiar with it. But I didn't keep up with that as I was kind of learning about it. So that's a good question, though.
Mm-hmm. Very good, very good. And just one more for you then. You went through a lot of the the system components here. And another thing we often get asked, right, is kind of buffer tanks and hydraulic separators, right? Some people may not even realize there's any difference between those two things. Are they the same thing? Is one better than the other? What do you have to say to those folks?
Well, okay, so that's probably going to be a personal preference. I mean, certain people are like, oh, well, hydraulic separators are the way to go. Buffer tanks are the way to go. Anytime we can add volume to a hydronic system is not bad, right? They're both going to do that because they give some additional volume to the system that can help eliminate on short cycling of the boiler, kind of help equalize some of those flow discrepancies we have in the pumps. If you look at a buffer tank, what's that? That's going to require more floor space, so that's going to have to be put on the floor. You can do some customizing on buffer tanks, different tapping locations. There's also standard offerings. And then when you look at hydraulic separators, those can also be used as air separators, just like a buffer tank can. You can put an air vent in there. It doesn't work as well. Um, and then also, there's these hydraulic separators have kind of became really all in one. You see them now with magnetic filters in them, removing dirt. So I think there's going to be more options with a hydraulic separator and kind of be a more universal kind of fix for you. So it's really going to be what you want to look for. Now, I don't know the cost difference for those, so you'd really have to look at that system need. If it's just a flow issue you're trying to resolve, probably a buffer tank may be more cost effective. I'm not 100% sure, but that's a good question too.
Gotcha.
But I have been impressed. I have been impressed with how the hydraulic separators have advanced over the years and have became this universal tool now.
Cool. All right. Well, there are a couple more questions here coming in too. Some a little bit more specific on the actual water quality, right? And so Aaron had mentioned a question here. You mentioned the 450 parts per million on the TDS. Wonder if you had any numbers on hardness and a couple other. But let's just start there with hardness. What do you got there?
Yeah, so again, I'm gonna make some assumptions here. I think they're in the manual. I didn't pull those exactly, but you should be able to get to those. And if not, we can get back to Aaron on what those would be, or actually we can get back to the group. But all that should be in the manual. I just kind of took one section out of the manual, so that was not every water quality parameter available.
And they would cover also pH and chlorine. He was mentioned about those as well.
Yeah, reading his quick. Yeah. So I think he was referencing here. I'm kind of reading too, assuming above and below. I'd have to look at the exact parameters. So yeah, those are good questions. And again, I think we're doing better. We probably may still have some voids that we need to fill, but we can reference the manual and get back to those. I don't have this off the top of my head. I don't know the specific numbers.
Gotcha. All right, we can certainly share those. All right, last question here: Apex versus amp, kind of the same size range. When do you use one over the other?
Okay, well that's that's a good question. So I think if I'm just looking at the products, right? The the Apex product has 5-to-1 turn down. The amp has 10-to-1. So if I'm looking at would this turn down matter for the system? So that could be when I look at the system requirements. Does higher turn down allow me to not short cycle as much? So that may help. The heat exchangers in those are a little bit different. So that's going to give you a little bit of pressure drop difference. So that could be a pump selection difference, pump energy usage. I haven't done the calculations for exactly that, but that could be something you'd want to look at. And then also you've got footprint. There is a footprint difference in those. So just like we talked about, there's a different heat exchanger which has different pressure drops. So the heat exchanger that's going to give you less of a pressure drop is going to be a little bit bigger. So that footprint's going to be a little bit bigger. So I think those are the things you'd want to kind of evaluate. Pretty similar control platform. So there's really no difference there. So it's really going to be around probably footprint, pressure drop, and turn down.
There we go. Very good. Well, that's all the questions we have here today. So yeah, I just want to thank everybody for joining us again, and thank you to Dan for going through this all with us. And yeah, hope to see you all next time. Thank you.